Myself, Sheikh Mahmood Sharif, and today's this slide introduces the topic probability theorem. Probability is a branch of mathematics that quantifies uncertainty. It provides method to predict outcomes when results are not granted. Applications span across science, engineering, economics, computer science, and every person like decision making. Example in real life are probability predicts whether it will rain, whether a cricket team will win, or the chances of drawing a lottery ticket. This is a roadmap of my presentation. In this roadmap, we will cover introduction of the probability theorem, definition of the probability theorem, types of the probability theorem, events and summary in the probability theorem. Introduction. Probability is the mathematics of uncertainty. It answers questions like what are the chances of something happen, used in science, economics, games, and daily life, as well as an example of a probability theorem that reporter says 70% chance of rain. This means that based on the historical data and models, rain occurs in 70 out of 100 similar conditions. Definition. Probability theorem are formal mathematical rules that describe how to calculate likelihood of events occurring, especially when the events are combined, dependent, or conditional. These theorems help us to reason about uncertainty using logic and formulas. Probability is a numerical measure of likelihood and the formula of probability is equal to number of favorable outcomes by total number of outcomes. And properties that P of E is equal to always in the range between 0 to 1, where 0 implies impossible event, 1 implies certain event. And the example of probability is tossing a coin. In tossing a coin, P of getting head is equal to 1 by 2. When 1 represents favorable outcome, 2 represents total number of outcomes. Another example is rolling a die. P of getting 6 is equal to 1 by 6. Importance of probability theorem that it provides a logical way to measure uncertainty. Here you can see the key points in definitions. Range 0 less than or equal to P of E less than or equal to 1. P of E is equal to 0 implies impossible. P of E is equal to 1 implies certain. Theorem of probability. A theorem gives rules about how probability behaves and how probability behaves when events interact. Why needed? Because real life problems involve multiple events. Examples are chances of rain and traffic jam together. Types of probability theorems. Additional probability. Probability of union of events. Multiplication probability. Probability of joint occurrence. Conditional probability theorem. Probability of event given another event. Boy's law. Updates probability when new evidence is introduced. Addition theorem. The addition theorem helps calculate the probability that at least one of two events occur. Formula of addition theorem is P of A union B is equal to P of A plus P of B minus P of A intersection. Meaning that implies probability that at least one of event A or B. In case 1, if A and B are mutually exclusive, that means cannot happen together. P of A union B is equal to P of A plus P of B. Example is tossing a die. Probability of getting 2 or 4 equals to 1 by 3. Probability of drawing a red card or a king from a deck of cards gives rise to P of red plus P of king minus P of red. And multiplication theorem. The probability that both events A and B occur is equal to the probability of A occurring multiplied by the probability of B occurring given that A has occurred. And formula gives us to P of A intersection B is equal to P of A into P of B by A, meaning probability that both events A and B occurs. If A and B are independent, P of A intersection B is equal to P of A into P of B. And the examples of tossing a coin and rolling a die. P of getting head and rolling 4 is equal to 1 by 12. Types of event. Simple event indicates a single output. Example, rolling A3. Compound event indicates more than one output. Mutually exclusive event indicates cannot occurrence together. An impedant event, extension event, complementary event indicates that one event that is opposite of another. Example of complementary event is event it will be rain versus no. Mutually exclusive means event cannot happen at the same time. Example, rolling a die, getting 3 and 5 at the same time is impossible. And we can have real examples like a person cannot be both passed and failed in the same attempt. The coin cannot land on the both head and train simultaneously. Independent event examples. Independent events are not related to each other. Examples are tossing a coin and rolling a die. Coin outcome does not affect die output. Real life examples we can see here that weather in Delhi does not affect coin toss result. Buying a lottery ticket does not affect whether it rains tomorrow. Real life examples we can see here that weather forecasting, medical testing, insurance, business, AI and machine learning, as well as sports. In weather and forecasting, we can use probability to predict rain, show and changes. In medical testing, probability is used to accuracy of positive or negative test results. In insurance, companies calculate risk of accidents, diseases to set premiums. In business sector, companies use probability to forecast demand, sales and stock marketing. In AI and machine learning sector, probability models are used for predictions. Sports and analysis use probability to estimate winning chances of the team. Example problem we can see that a dice is rolled and the P of getting number less than 4 or greater than 4. If we take P of getting greater than 4 and the outcome is 5, 6 means 2 by 6 is equal to 1 by 3. And P of getting even number and even numbers less than 6 are 2, 4, 6 and we get 1 by 2. More examples like probability of drawing an ace from a deck is equal to 1 by 13. Probability of tossing 2 heads in 2 flips is equal to 1 by 4. Probability of rolling 2 6 in a row is equal to 1 by 36. And we can see a summary here that probability measures uncertainty and helps make predictions. Key theorems: addition, multiplication, conditional probability. Types of events: simple, compound, mutually independent, complementary, and applications of probability theorem given that whether medicine business, AI, insurance sports, and daily life. Understanding probability gives better decision making power in uncertain situations, and it is very useful in present situations. And finally, conclusion. We have conclusion that probability theorems reminds us that uncertainty is an inherent part of life. By embarrassing this uncertainty, we can develop a deeper appreciation for the complexities of world around us and make more informed decisions in the face of unknowns. This concludes through highlight the significance, application, implications of probability theorem, emphasizing their importance in our life and decision making process. Probability theorems are more than just what mathematician concepts. They are powerful tools for navigation the certain world around us. By embracing this theorem, we can make more informed decisions, making this and unlock new possibilities. This concludes summarizes the importance of probability theorems and their applications, while also highlighting the potential for growth and future growth and impact. Probability theorems helps us measure and manage uncertainty. Theorems like addition, multiplication, guides and accurate calculations. Events are classified as simple. Compounds, exclusive or independent real-life applications include weather, medicine, incidents, games. Overall probability builds a foundation for statistics and better decision making. Thank you.